next concept, that is probable error and interpretation of correlation coefficient. So after calculating this rank correlation, that is Spearman's rank correlation, so what is the error it can be occurred with this rank correlation? So while we are framing the hypothesis, we are doing the confidence level of hypothesis. Why? Because if when we are applying a test statistic, we have some confidence limit and some failure ratios. So what is the confidence limit and what is the failure ratio? We will find out according to the assumption or according to the hypothesis. So like this, what is the probability to fail that rank correlation? How much it is significant? We can identify with this probable error. So that is the expected error in correlation is nothing but the probable error. So when we are making that correlation coefficient, that is Spearman's rank correlation. So what is the expected error we can occur? Means it can occur with the problem. So that error is nothing but probable error. So to calculate this probable error with the help of this correlation coefficient, that is the formula. Here we can use probable error is equals to 0.6745 into 1 minus r square by root n. So where r is the Pearson's rank correlation or Pearson's correlation coefficient, then n is equals to sample size. Okay, what is the total number of samples, and 0.6745 is a constant, relates to normal distribution. Okay, we know that 0.6745 is a constant, it is means working on normal distribution. So that is 0.6745 into 1 minus r square by root n, that is the formula for probable error. So next example we can take here, r is equals to 0.80, n is equals to 50, and probable error, that is equals to how much we need, means how much we have to calculate here. So to calculate that probable error, what is the formula? 0.6745 into 1 minus r square by root n. Then here we can take probable error is equals to 0.6745 into 1 minus 0.80 is the rank correlation coefficient. So 0.80 square, we need square here, 1 minus 0.80 square by under root 50, that is 50 is the sample size. So under root 50. So here simplifying this, 0.6745 into 1 minus 0.80 square, that is equal to 0.640. Okay, 8 8 is 64, then 0.640 is the 1 minus 0.640 by root 50, then 0.46745 into 0.36, that is 1 minus 0.64 is equals to 0.360 by how much it is root 50, that is equals to 7 7s are 49, then 7.071 approximately, that is equals to root 50. Then here to simplify this, 0.6745 into 0.360 by 7.071, that is equals to probable error is equal to 0.034. So here to compare coefficient of correlation with this probable error, so we have to do this 6 into probable error, that is the standard formula we can use, 6 into probable error. Though so here 6 into 0.034, already we got this probable error 0.034, then 0.204, that is the value. If that probable error is more than our coefficient of correlation, that is not significant. Okay, if it is the probable error is less than our correlation coefficient, then that correlation coefficient is significant. That relation we can believe that correlation coefficient. It can be, what is that? It can be believed. It means it can be helpful. So here since 0.80 is greater than 0.20, for probable error is less than correlation coefficient, then it is a significant. Okay, we can it can be correct, it's significant, it can be correct, that is the correlation coefficient is can be correct. So that is the situation we can use with the help of this probable error and that interpretation of correlation coefficient. So this is the matter. What is that? Probable error is nothing but expected error in Spearman's rank correlation. Then to find out this probable error, we have the formula, that is 0.6745 into 1 minus r square by root n. R is the Pearson's correlation coefficient, n is the sample size, and 6745 is the 0.6745 is the, it's a constant which works in normal distribution. Then example we have taken here, r is equals to n is equal to, then we calculated the probable error. Then after getting the error, to compare this error with the correlation coefficient to check the optimality of the correlation coefficient, then 6 into probable error we have to do, that is 6 into 0.034, 0.0204. When we are testing that correlation coefficient is adequate, then we have to check it whether correlation coefficient is more than probable error, that correlation coefficient is significant. If it is correlation coefficient is less than probable error, that is insignificant. That is not a significant correlation coefficient. So this is the concept related to the probable error and its interpretation on correlation coefficient. Next concept, that is linear regression and least squares method. So after correlation, here correlation means a relationship between any two variables. So in the situation we are considering while collecting the data, how many number of variables are there affecting the situation instead by application of the statistics. So correlation is the one of the statistical method. So while applying this, we need to gather the information. So after gathering the information, in that information, how many number of variables are there to affecting the situation, here we are considering. So here, while correlating those variables, here from the correlation concept, we will get either those variables are positively correlated or negatively correlated. So that magnitude we will get here means that much of a relationship we will identify from the correlation by using the Carl Pearson coefficient of correlation or Spearman's rank correlation or concurrent deviations method, whatever that is, we can identify that just the relationship between the variables. So coming to the regression, regression is nothing but it is that how much variables are related to each other. For example, correlation is positive. For example, we are taking the consideration of demand and price. So both are negatively correlated. If demand increases, price increases, demand decreases. Price decreases, demand will increase. So here we know that from the correlation concept, those two are negatively correlated. But how much that magnitude of that correlation? So what percentage of the relationship will be there? Of course, that may be a negative or positive. So how much that percentage of the relationship we can identify from the regression lines. So that line means a linear regression. Linear regression means a regression or nothing but a relationship of any two variables framing their linear relationship, nothing but which is framing a line equation. So we can represent the relationship between the variables in the form of equations, in the form of straight line equations, is nothing but regression. When we are getting that regression equations which is forming a straight lines is nothing but linear regression. That is, here we have not, where we have the formula y is equals to a plus bx. So a plus bx means here the relationship between two variables. It is an equation. So ax plus by plus c is equals to 0. That is the line equation. So a regression coefficient or a regression is framing a straight line is nothing but the linear regression. So here linear regression means line equation. It has to be formed. So here that correlation is helpful to identify the relationship between the variables, while how much those variables are related each other. If x increases 10%, how much y is going to decrease? How much percentage of the y is going to decrease in every situation is nothing but the regression. So we can identify that regression, that relationship, that magnitude, that percentage change with the help of equations from the regression. Those equations are nothing but the line equations. That regression is nothing but linear regression. So to identify the linear regression, to frame that equations with the help of the linear regression, we have the least squares method. So to identify this means to calculate this least squares method, we have the formula, that is the main equation for this least square method, that is equals to y plus bx. That is the line equation that represents the linear relationship between the variables y is equals to a plus bx. Then to identify means to calculate the a comma b values. Here y we know what is y intercept, x intercept. These are all the values we will get it from the question. So we have to find out this a comma b values. These a comma b are the constant values we have to find from the given information. To find out that to find out that a comma b values from the given information, we have two more equations we have framed, that is sigma y is equals to n into a plus b into sigma x. Similarly, sigma xy is equals to a sigma x plus b sigma x square, where sigma y is equals to total number of y series, sigma x is equals to total of x series, means we will get the two series of data. Why? Because we have to identify the relationship between the two variables x and y. So here we will get it for two series of data. Then the total of y series, that is sigma y, the total of x series, that is sigma x, and n is equals to number of observations. Sigma xy is the sum of xy series, nothing but the product of xy series, the sum of xy column. Xy column we will find out. Xy column means x product of x and y. Then sigma x square is nothing but square of x series. So that is the information and the equations from the least squares method. So consider one example here, that is here x series data and y series data, 2x and y. So what is it? 2, 3, 4, 5, 6, that is the x values, and coming to the y values 7, 9, 10, 14, 15. These are all the y values. So coming to according to the equation, what we need, y is equal to a plus, to frame this equation, sigma y we need, sigma x we need, sigma xy we need, sigma x square, means sigma x and sigma y, sigma x, sigma y, sigma x square, sigma xy, sigma x square. These four values we require. So for this purpose, we have to calculate, that is sigma x. X is x series. This is x series. So this is y series. So sigma x means 2 plus 3 plus 4 plus 5 plus 6. 2 plus 3 5 plus 4 9 plus 4 14 plus 6 20. Similarly, y series sigma y 7 plus 9, 16 plus 10, 26 plus 14, 40 plus 15, 55. So this is sigma y. Next, coming to product of x and y, that is sigma xy we need. So first we need to do the product of xy. So that is 2 into 7, 14. 3 into 9, 3 9s are 27, 4 10s are 40, 5 14s are 14 5s are 70, 15 6 are 90. That is product of x and y. So here we need to calculate the summation of xy column. That is 14 plus 27 plus 40 plus 70 plus 90. The total of sigma xy, that is xy, the series total is 241. Then coming to, we need one more column, that is sigma x square. According to this equation, we need xy, sigma y, sigma x square. Then sigma x square, we need to square of x series, that is 2 square 4, 3 square 9, 4 square 4 into 4 16, 5 square 25, 6 into 6, that is 6 square 36. So that summation of this x square series, that is 4 plus 9, 13 plus 16, 29 plus 25, 54 plus 36, 90. So here that is the sigma x square we have, sigma xy we have, sigma y we have, sigma x we have. Then we have to substitute all these values into the equation of linear regression. So to frame this equation, first finally we will get, that is y, how much y depends on x. Similarly we can take the equation, that is this is y depends on x. One more equation, that is equal to x is equal to a plus by. This is how much x depends on y. Means here the both the ways we can have the dependencies, means sometimes x may depends on y, sometimes y may depends on x according to the situation. So this is the linear regression for x, y on x series, y on x. So similarly, to frame this y is equal to a plus bx, we need to calculate the a comma b values. For that purpose, what we did, substitute the above values into equation 1 and 2 equation. These two equations we have to substitute. So for this purpose, what is that values? Sigma y, how much sigma y? 55 is equal to n into a plus b sigma x, that is equal to 55 is equal to n into a, 5 into 5, n means 1 2 3 4 number of observations, 5a plus b sigma x, b already as it is b, sigma x how much it is, sigma x already we got calculated, that is 20. So 20b, that is the first equation, 55 is equals to 5a plus 20b. That 55 is nothing but sigma y value, that is 55, 5a, 5 means n value, 5 observations plus 20b, 20 means b into sigma x is equal to 20, 20b. Similarly, second equation, how much it is? Sigma xy is equals to a sigma x plus b sigma x square. So sigma xy how much it is? 241, that is equal to 241 is equals to A sigma x. How much sigma x? 20. 20A plus B sigma x square. Sigma x square over 90 into B. B as it is. B into sigma x square 90. 90B. So these two equations we have to solve. To solve these two equations, first we need to 4 into equation 1. So we have to multiply that equation 1 with 4. Then 4 into 55 to 20 plus 4 into 5a 20a plus 4 into 20b 80b minus then second equation 241 is equal to 20a plus 90b. Then we have to minus those two equations minus, then we can change the signs because while solving the equation, then minus 241 plus 220 minus 21 is equals to 20a minus 20 plus 20a minus 20a gets cancelled plus 80b minus 90b is equal to minus 10b. Then minus minus gets cancelled, then 21 is equal to 10b. Then it implies b is equals to how much? B is equal to 21 by 10, that is equals to 2.1. Then similarly, we have to substitute this way b value into the equation 1. This first equation we can substitute. So that is 55, that is 5a, 5 into a plus how much it is? 20 into 2.1 is equals to 55. Then by substituting this value into this equation, then we will get 2.6. B value will be 2.6. A value will be 2.6. B is 2.1. A is 2.6. Then substitute this A comma B value. Substitute these A and B values, that is 2.6 and 2.1. Then y is equals to 2.6 plus 2.1 x. So this is y on x. This is the least squares method in linear regression. Next, relationship between correlation and regression. So already we discussed some little bit about the correlation and regression relationship. Here the correlation is nothing but a relationship between any two variables. While coming to the regression, we are identifying the how much those two are related each other. So here the first point, what is that? Only nature and extent of relationship. Here in the correlation, we can identify the nature of the variables and also what is the relationship between the variables. Either it may be positive relation or negative relation, or dependency is there or not, or independent means dependent each other. Whatever that is, what is the we can identify that relationship between the variables. Either both two are related or not. That's we can identify from the correlation. While coming to the regression, what is the regression? Impact of independent variable and dependent variable. Here, in correlation, only we are identifying the relationship between the two variables. Coming to the regression, how much both two variables are related. Here, nothing but we have to identify in the regression, we have to identify both independent variable and dependent variable separately, because dependent variable, how much it depends on independent variable. If demand and price we will take. So in correlation, we should not take it as both are dependent or independent, or which one is independent or which one dependent. We should not identify from the correlation. Only we can identify whether both are related or not, we can identify from the correlation. But in case of regression, we have to we must be identify which one is independent and which one is dependent. So here coming to the demand and price, always demand must be dependent on price. Price is always independent variable. Demand is depends on price. So here we have to segregate the dependent and independent variables in the regression lines. That is impact of in regression. What is the impact of independent variable on dependent variable? If for example, how much independent variable increases, then how much dependent variable is going to change, either it may be increase or decrease. So that is the first point will be described as correlation regression difference. Next, coming to the second point, what it is, it may be positive or negative. Clearly in the correlation, we will get the answer. Finally, we will get one coefficient of correlation plus or minus something. So that is, it may be positive or negative. Coming to the regression, it may be positive or negative. It is also will be getting the positive or negative, but it indicates that the magnitude of the relationship means it can frame a linear relationship. That is, linearity will be there. Linearity between the means here nothing but the magnitude indicates the linearity, positive or negative. but how much positively related and how much negatively related, it is going to be what is that going to be identified from this linearity. So that is linearity between the variables. Next, third point, x and y are the variables, means here only we are taking the x and y as a variables. Coming to this regression line, x and y both we have to identify, and both which one is which one is dependent variable and which one has to be independent variable, we have to identify from the regression. Then coming to the correlation rxy, that is correlation coefficient rxy is equals to ryx, means relationship between x and y and y and x both are equal. But in the regression line, regression coefficients bxy, means b x depends on y and y depends on, both are in different ways. Okay, this is the relationship between the correlation and the regression.